Section 6.2, we skipped section 6.1 because that was just all that practice with the ratios, which is all the stuff that you guys did online. So 6.2 gets us into the proportions to solve geometry problems. So if we look at proportions within a triangle, of course, this is going to be slow for me. Are we there? So here we are given a triangle, right? We have a line inside of the triangle. I don't necessarily know that that line's a mid-segment because I'm not told that B and E are midpoints. So I don't quite know if that is the middle or not. But what's going to happen is when you have a triangle and you have some type of line inside the triangle, you're going to have a proportion created with given side lengths. Now, if I said to you, could you trace over the line segment AB? Would you be able to do that on the diagram? Yeah, you don't have to do that. I'm going to do it because I can do it in a different color. So line segment AB is right here, is 12, right? Where's line segment BC?
Right below it.
Right below it. So I should probably have done this. Purple. There we go. Where is line segment AE? It's right here. Good, so I'm going to make that green. And then line segment ED is down here, which I'm making orange. Out of those four things, how many of those do I know lengths of?
2.
I know 2. I know the purple is 12. I know the green is 18. So now what I can do...
Well, actually, technically 3. Because, I mean, the math is there to figure out ED.
It is. The math is there. Does everybody see why the math is there to find ED? What would be orange?
Wow. 18.
Not 18. If A
18.
to D is 33... 33 minus 18, so 18 plus 2 is 20. 20 to 33 is 13, so 13 plus 2 is 15. So we know that ED is 15, so let's fill that in. Okay, so now, if we were given a proportion, let's go ahead and now put numbers in place of these lengths. Because remember, whenever there are 2 letters without a line above it, that means we're talking about the length. So the length of AB, we know, is 12 over the length of BC. Do we know that? Nope. So I'm going to put something unknown, X, is equal to the length of AE, which is 18, over the length of ED, which we calculated it to be 15. Can we solve for X now?
Yeah.
Sure. Let's do some cross multiplying. So 12 times 15. Oh boy. What is that? 12 times 15 is 180. Is equal to my other cross product is 18x. So what does x equal? 10. What did x represent?
BC.
BC. What were we asked to find?
BC.
BC. So the length of BC is equal to 10.
How exciting.
Okay? How are we feeling about that? Good? All right, so let's move on to number 2. We're going to do the same thing.
Oh my goodness.
Wait, we skipped
they
the
got
first one.
switched. So,
I skipped the first one.
No, so what you did for number 1, that was our number.
That was your number 2?
Yeah.
Ah, bummer. All right, so now I need to jump up to number 1.
Yeah.
All right. Did you guys do that work for number 2, or did you do it up at number 1? Did you guys all catch that?
At number 2.
Okay, perfect. All right, so number 1, I think what happened was when my Apple TV was not transferring, right? Okay, so let's try to do this one. So AB, do we know the length of A to B?
Yes.
What is it? 6. So let's put a 6 in the top of my fraction. Do I know the length of BC?
No.
No, so we should put X equals. Do I know the length of AE? 12 over the length of ED, which is 4. Cross multiplying. 6 times 4 is 24 equals 12 times X is 12X. Dividing by 12 gets me X is equal to 2. Oh, I'm not done. What did X represent? BC. So BC is equal to 2 should be my final answer. Okay. Not too crazy? All right. So now let's jump down to number 3. So here's the proportion given to me. It's telling me my proportion is FD. So do we know the length of F to D?
Yes.
What is it? It is 12. 9 plus 3. So FD is 12 over F to E is 9 equals C to D.
Wait, I have a question.
Yeah,
Why did you do the whole length of FD?
because this ratio is telling me I need FD.
Oh, I didn't even. Oh, okay, yeah.
I always go back to the ratio, to the proportion. So CD is 16 over BE. Do we know BE? Nope, so let's make it an X. Cross multiplying that gets us 12X is equal to 16 times 9, 144. Divide by 12. So X is equal to 12. What did X represent? BE, which is what we were asked to find. So BE is equal to 12.
Do you have to put a. Should we be putting a line over B?
No, because we're talking about the length of it.
Yeah, but isn't the length of line
So if we-
segment BE 12?
Well, if you wrote it out as the length of line segment BE. But remember, just two letters with no symbol above means the length of BE, the distance between BE. That's our symbol notation.
Okay.
Okay. All right, flip on to the back. Now we no longer have a triangle, we have a quadrilateral. But same rules are going to apply. Looking at your proportion, do I know what AB is? Nope, so we're going to make that X over BC, which is 5, is equal to FE, which is 4, over ED, which is 6. Cross multiplying that gets us 6X is equal to 20. Dividing by 6. I prefer fractions over decimals, so just reduce that. What can I take out of both 20 and 6? If I take out 2 from both of those, then it's going to simplify to 10 over 3. So AB was where my X was. AB is 10 over 3, right? 'Cause that's what represented my X. But I'm asked to find A to C, which means what do we have to do to that 10/3? Add it. Ugh. So AC is equal to 10/3 plus 5. How do we add that? Well, those that have,
Can you just do 15/3 and then reduce it?
yeah, we could easily do that. Did it by hand. So make a common denominator, 15/3. Because 5 is the same as 15/3, so that'd be 25/3. Those who have calculators that do fractions, remember that fraction button that I showed you guys? So you could just do on your calculator 10 and then hit that A, B, C button or whatever it is, and then 3 and then plus 5. For those that have the A, B, C button on there, which is, 8 1/3. And then you could then you can do that improper to proper fraction button.
You smell like the smell of the certain room at the dentist. It smells good though.
Okay.
But that's what it smells like.
AC. Yeah, doesn't this one convert from improper to proper fractions? Yeah. If you hit second and the ABC button, and then it should take it to the 25/3. Yeah.
I didn't even know I could do that.
Yeah. Okay? We're good with that? All right, so the only thing that we need to cover in this section is scale drawings. So a scale drawing is, a scale is the ratio of any length in a scale drawing to the corresponding actual length All right, so if you think about blueprints, a blueprint is something that is much smaller than the actual object that is being created, right? So it's drawn to scale, and there's a specific scale that they use. So a scale drawing is a drawing in which all lengths are proportional. Yep.
And they have to do with maps.
Yeah, maps have scales on them. Like the key shows for every inch is so many miles or something like that. Yeah. So where lengths are proportional to corresponding actual lengths.
Wait, maps are drawn to scale?
Yeah, oh, yeah.
I didn't know that. I thought they were just drawn to be small.
No.
Like the bottom right, it'll show you like.
Yeah, there's that
so
line.
many-
I never.
Yeah, it's like so many inches equals so
I
many
didn't.
Miles,
I've
yeah.
never looked at that like closely. I didn't realize that's what it was.
Yeah. I mean, who uses maps anymore? All right. Just use Google Maps. Tells you where to get everywhere. Okay, so for this last example, it says 2 cities are 3.5 inches apart on a map with a scale that every 1 inch is equal to 50 miles. What would be the actual distance? So 1, we could just set up a proportion. We know that every 1 inch is equal to 50 miles, so I can turn that into a ratio. Is equal to 35 inches would be how many miles? So cross multiplying that gets us 1x is equal to whatever 3.5 times 50 is. Is that what it is? So 175 miles. Okay. All right. Proportions within figures. All right, let's do some practice problems.